It's quite easy to understand what we mean if we say an event causes something to happen. For example, drinking too much alcohol and then driving a car can cause a road traffic accident. Now that's easy to understand because we have everyday knowledge about the effects of alcohol on driving. When we're doing research, however, we're starting from a position of limited knowledge about the subject we're studying. So how can we go about discovering whether something causes something else to happen? One way is to look for a correlation, in other words, determining whether two things change in step with one another. A famous example is provided by the debate around global warming and carbon dioxide emissions. There's a correlation between carbon dioxide levels and global warming, and the correlation can be seen on the World Wide Web, and if you look at the written version of this presentation, you can see the link presented there. Let's start with an everyday example. Suppose we're interested to know whether the increased use of computer games is a cause of obesity. Perhaps playing computer games causes people to lead less active lifestyles, and so they become obese. We could look to see if there's data available for computer games sales over the past 20 years, and look for the proportion of people who are recorded as being obese over the same period. If we saw that the game sales and obesity increased around the same time, we could say we've identified a correlation. But that wouldn't necessarily mean that computer games cause obesity. There are several reasons why this correlation might exist, even if playing computer games doesn't cause obesity. Firstly, the correlation might have occurred by pure chance. Sound unlikely? Well, let's take another example. Suppose you notice the amount of junk mail that's delivered to your house varies from week to week. Now suppose you measure as many other weekly events as you possibly can. So for example, how many times you saw a cat, how many times it rained, how many times you had to stop at a red light on the way to work, how many days you had toast for breakfast, and so on. If you look at enough of these events, you're almost certain to find one that has the same pattern of changes as the changes in junk mail delivery. In other words, if you look at enough things, correlations inevitably exist by pure chance. The text version of this presentation lists a website that provides hundreds of crazy correlations that have occurred by pure chance, but one event does not cause the other, and I'd encourage you to go and look at that website. Secondly, correlations can occur because of something called confounding factors. Here's an example of what I mean by that. It has been suggested that there's a correlation between sharks attacking humans and ice cream consumption. Now, no one is suggesting that sharks are chasing people who are swimming whilst eating ice creams. However, people do tend to eat more ice cream in the summer, and of course it's in the summer that people tend to go swimming in the sea, and that of course increases the chance of a shark attack. In other words, the hot weather creates a correlation between ice cream consumption and shark attacks, even though one has got nothing to do with the other. Thirdly, it's difficult to infer the order of events from a correlation. Going back to our obesity and computer games example, we initially proposed the idea that playing computer games leads to obesity. But isn't the opposite also possible? That obesity, brought on by other factors, leads to people following less active hobbies, such as playing computer games. In this case, obesity is causing the computer game use, rather than the other way around. Fourthly, some correlations are absolutely inevitable. For example, there's a very striking correlation between marriage and divorce. All people who get divorced have been married before. So does that mean that marriage causes divorce? I'll let you decide that one. To summarize all of this, here's a diagram which shows potential explanations for why a correlation might be observed between two events. I've called the events A and B. In the first case, A and B correlate by pure chance. In the second case, A causes B. In the third case, B causes A. And in the fourth case, A and B are not related directly, but X causes both A and B. So hopefully you can see that correlation is really only a starting point for investigating something, and we need to do that by designing an appropriate experiment. So how could we test if computer games cause obesity? Well, we could encourage people to play computer games every day for several months and see if they become obese. Then we could take away the computer games and see if they lose weight. This is called a prospective trial because we start with the hypothesis that computer games cause obesity and directly test what happens in the future when we carry out a specific intervention, in this case making people play with their computers. This is much more powerful than looking at historical data because we can repeat it as often as we like to rule out correlation occurring by pure chance.